very much for attending this webinar. My name is Phuc Tran. So for all of you who don't know me, because this is now the second webinar or in regards to additive manufacturing software. My name is Phuc Tran. So I'm working for CoreTechnologie for more than 8 years. First in the application, now in technical sales to show and present the software to find solutions based on customer needs. And next to me is Laurent Hartmann. I think he can introduce himself.
Yeah, hello everyone. My name is Laurent Hartmann. I've been in CoreTechnologie for almost 2 years now, and am in the additive manufacturing department. So I'm the technical expert, I would say, for additive manufacturing.
That's perfect, because you are the expert and you will definitely can give us some more information, more detailed information, technical information on the products. So today we will focus on the Partfinder and the connected, the new technology, batch nesting. So first of all, I would like to give you some facts and figures about the company, about some products of us, the main products, and then I have prepared some slides to give you detailed information about the Partfinder, and I will show also the Partfinder live. I will create you some filter criteria, and before we're doing that, we will analyze one folder to see how the Partfinder is working on the side of the user. So first of all, CoreTechnologie. Who is CoreTechnologie? We are providing, we are developing and providing software for CAD interoperability, for viewing, for integrating SDKs for software, for other software. So we have more than 20 years experience in this area, and we have over 800 software customers who are using our viewing tools, conversion tools, and moreover, we have 30 software partners who had integrated our solutions in their software. So later on, I will explain to you which products. So we are headquartered in Germany, near Frankfurt, and we have our main development centers in Lyon, in France, and enhanced to Morocco. So additionally, we have subsidiaries in France, so in India, Italy, Japan, in Great Britain, and in the States, and worldwide, we are around 100 employees. So our analyzer offers a range of CAD formats which can be imported into the software to read and to make some section cuts, to make measurements functions, to export to JT, to 3D PDF, as well as to do analysis functions like comparison, collision detection, wall thickness, undercut, and draft analysis. So this cost-effective CAD viewer is a standalone tool, and next to it we have our flagship 3D Evolution to convert files. Yeah, for example, like CATIA, NX, Creo, FBX, SolidWorks, Inventor, and more, which are supported here in this software. This software is Daimler certified due to the JT converter, and we have a feature-based conversion with full parametric translation. So based on the features in history, which will be natively read out in the software. There are some highly technical functions for healing, yeah, to maintain the quality of the models, and also the analysis functions like model comparison and so on are also available in this modular-based software, and all the functions which has been mentioned here now can be run also in the automatic mode. So in the batch mode offers the integration into the PDM, into the PLM system. So there are no restrictions. And in the last webinar, we mentioned, or we presented for the first time in the webinar, the 4D additive software. I would like only to summarize also this software solution to prepare CAD data for the upcoming 3D printing. So here in this case, you can import all the data formats. Yeah, this is possible. So you are really independent of tessellated geometries like STL. So you will be able to read CATIA files, NX, and so on. And you can do real-time surface quality analysis to keep your best quality result in the end. You can do analysis functions like massive zones, wall thickness due to the technology of the machine. And additionally, you can modify geometries, do direct modelings, do geometry simplifications like hollowing, and creating lattice structures to keep the strength of the models. And the unique texturing tool gives you and your design department really nice haptics and optical aspects of your models. Yeah, especially for the designing interior designing department, for example. And the automatic 2D and 3D nesting, which is also available in the interactive mode, which will be shown later by Laurent, in this case, but in batch mode. So now I would like to start with the this slide is a repeat from the last one here, because I would like to give you the idea why the Partfinder technology is really important, because this additive manufacturing is, yeah, let me say, increasingly changing industrial production technology. So yeah, many companies are faced with the challenging of identifying parts, yeah, that are suitable for the new manufacturing process. In this case, you see that the additive manufacturing workflow starts with the designing. But if you have a conventional designing department, so therefore we have a huge gap, yeah, between the designing and the AM process, because before you do the pre-processing to do the quality check, the healing, the positioning and nesting, you need to find, here in this case, you need to find or identify parts which is suitable then for your new manufacturing process, so for the additive one. And then you need to filtering out, yeah, these suitable parts from the existing database of your 3D models. This is the core problem, because the core problem is that you have a large database, yeah, and this takes so much time This is incredible. This is incredible to do that. Yeah, by human eyes, by manual processes. So in the last webinar, we have presented for the additive. So please let us know also after the webinar if you have interest to see the 4D additive again, to have a demo on it. Also for the Partfinder, to do that on your machine or to do a pretest with us to check and to see how is that working with your files. The main, also one of the main advantage with this solution is that we are always first working with or based on exact BREP geometries. So that means not with STL or tessellated geometry to maintain the best quality of the models. So let me continue with the information on the Partfinder. So I have here prepared some slides about the Partfinder to give you first all the details. First of all, the Partfinder is created to identify parts which should be then suitable for different additive manufacturing processes. And in this case, Partfinder is able to read out all the information of the card files, of the native one and of the standard one. So directly out of the data, we take all the information. That means like designing elements, the exact geometry. We analyze them to do wall thickness. We do massive zones analysis. We take all the attributes and the PMIs tolerances. So to have all these in our internal SQL database, which is there stored. And yeah, and then afterwards you can do freely customized filterings to do yeah, or to set up criterias, and this is what we will do also live. So I will do that live with you to see and to based on an example, for example, HP multi-jet fusion printer based on the bounding boxes, on the printing volume, and then you will recognize how the software is working. The one also one of the beneficial points is that in this software you will have on the HTML side, you will have also a 3D graphic, which is really nice to see on a really clear list, and the model, which is then yeah, visible in the end. So the multiprocessor calculation gives you a really fast process, yeah, for really very large amounts of data. So these are some examples on the right hand, which CAD formats will be presented. So we have totally 24, around 24 different CAD formats. We read them out, so that means the exact BREP geometries, the tessellation as well. If you have only STL files, for example, all the attributes will be received. History, features, parametrics will be opened, will be taken out, and all the PMIs, product manufacturing information, and as well as the yeah, the data will be checked due to the consistency, quality, and how to work on these files. Based on the cut data, the Partfinder will analyze the geometries directly for you. So that means to classify the models in the end, we will do analysis like wall thickness, yeah, to have an idea how thick is or are the models. So if you have some areas which is much more thicker than somewhere else, and this is not optimal for your printer, then this software is filtering out. So, so that means it's really flexible in use for various additive manufacturing methods and machine types. Yeah, so it's also fully independently to be integrated in PLM system, and also next to the wall thickness checking, the volume, the bounding boxes, the internal backlashes and drafts will be calculated in this process. And furthermore, as mentioned, the attributes PMIs are available then and will be also used for the filtering. So how does or how does that looks like? So here on the right hand, you see the software in the interactive mode. That means you open manually the model. But here in this small window, mass properties here in the middle of the screen here, you have an idea which values will be taken out and will be saved in the SQL database. So that means like volume surfaces, minimum bounding boxes, the coordinate systems of the bounding boxes, all the bounding boxes of the parts and assemblies, and all the moments of inertia information. And also the features history. So that means if you are having a huge database of SolidWorks, of CATIA, of NX, of Creo, they will be opened independently of these, let me say, cut licenses. So that means the files will be read binary, and all the informations like Boolean operations, like draft, like rounds and extrusion and chamfers will be read, yeah, in these in this case. So therefore, the complexity of the model is really unlimited in this case, and through our API in our software, it, it is always possible to enhance the possibility of supporting special features. Yeah, so the enhancement is unlimited. So these are the attributes or the properties, yeah, which is commonly in the CAD. For example, here in the CAD v5 file, yeah, you have here the information of the user, and these filterings here in this Partfinder will be shown them by me during the live presentation. Here in this case, I would like only to say there are a lot of criteria which can be used, like based on the part properties, metadata, or based on the analysis results. That means here the thickness average rate should be greater than, but it should be less than. So that means you can use and or not logical links and interval definition, like greater than and less than. So we have a range of values can be used. And this is what we will use then afterwards. So this will be a presentation of the search results, and this is what, I will show you that also live. So you have here on the right, on the left hand, the model pictures, and here the file names, Cad formats, the size of the file, modified date, and also download the file as well as to see the model. And these information are saved in the actually in the SQL database connection to the PLM system. So, okay, so I think we can go now to the software. So just a quick information to you. If you have any questions, you can please write in the chat of this webinar software. And yeah, we are happy then to answer you the questions live, or we are writing the answer also in the group. So let me start with the manager here. So first of all, based on this manager, it will the Partfinder will be, let me say, managed and controlled by this manager to set up the configuration. How many calculation processor do you have to be faster in calculation of or analyzing your models, and as well as to set up the SQL database. So let me go to the web interface. I have already opened this one here. And so first of all, I go to the Partfinder. And now in this case, you see already some results. So let me go to show you from the beginning, to run with you one analysis of the folder, because in this case, we want to analyze one folder in which some parts are inside. So I will show you now. Let me take just an example, the folder support. So we have here totally 3 models. Parasolid models and step models. So around 1.3 until 2 meg, so it's not a problem. So let me go to this path. So I can, so you see I have run this morning, so 40 minutes ago. I have already done some jobs here inside, but I will restart one and change just the folder. So support, because this is what is not done yet. So, okay. So now I set up some options like counting features. Yeah, to count, okay, how many extrusions would you have, how many rounds would you have, chamfers, and so on. It should calculate the thickness based on the array, because this is much more quicker, yeah, for the computation. And this is the timeout if something is happening and the software is freezing or somehow, then we should not wait longer than 3 minutes. So I click on run and go to the batch manager, and to see, okay, this is now in process. And during that process, we can check also here in the log file, which will be always be saved on the local machine or in the calculation machine, which directory is our input, and which options are activated or not. And we see here now, okay, some jobs with specific IDs have been added into this process. So that's great. So we have 3 parts. One part takes around 10 seconds. I think it's really quick. So let's go to the Partfinder inside, and now we have totally 13 elements. And now I would like to explain to you first what we can do with this list here. Yeah, so first of all, we see the picture. If I hold my left hand mouse, we see the file name. Okay, this is a step file. We see how big is that? Yeah, which is the value of the volume, the bounding boxes. So how big is the file, and the ratio of surface and volume, as well as if I click on here to see more details of the model, because it will be necessary to see the attributes, for example. It's a arrow SLM. Okay. This file is a step file from CATIA originated. Application protocol 214. We have a CATIA release. Okay, this is not really important for now. We have our mesh properties here: area, volume, surface to volume ratio, bounding boxes, and as well as the thickness. So this is a really nice tool to have the wall thickness here, yeah, of the model here. So the average is 17.56, and we have here median value, a standard deviation, yeah, and the first and third quartile. So here are the CT features. So in this file, we don't have anyone because obviously this is one like an imported geometry. But anyhow, we have CT, we have geometries or simple entities like faces, like cones or cylinders, edges. How many bodies we do have here? So okay, obviously we have only one, and we have sphere faces, yeah, totally 48 here in this model here. So it's really good to have this information because now, okay, no, just a second here. We have here native in the features here. So that means we have features here inside. So to will be explained here. Okay. Now, in this case, to find or to identify suitable parts for your machine is, first of all, we want to have a resulted list and all the parts which are really suitable for your printer. Therefore, we need to create a filter to say, okay, these models should be printed out. So I will now take an example with the HP printer. Therefore, I enter just HP. You can take, for example, also your other namings or your machine name. So here in this case, we have a lot of filters and criteria like bounding boxes, area, volume, volume to ratio, area ratio, attributes. So for example, all the models who has been created by a specific, by one engineer or with his naming or or here assembly constrains a part with a name. Yeah, for example, you don't want creating a really expensive tool for plastic injection molding. So therefore, you want to have all the parts which have a name with a plastic, for example. Yeah, so then you can use it as well. Here in this case, first of all, I would like to use the bounding box because I think this is a really important thing to limit to make a limit of the models. So if a model is smaller than a possible volume, printing volume, then you can be sure that the model can be printed without cutting the model. So cutting tools are also available in the 4D Additive, which has been presented in the last webinar. But if you want to see that, the cutting, then please let us know. So now I take, for example, the bounding box is should be less than, so all the bodies with the bounding box should be less than, like, for example, 380, right, is 284. I think these are the values of HP printer law. Can you confirm that?
Yes, that's correct. Perfect.
Perfect. So, okay, let me add a criterion more, like, for example, thickness. Let me go to a thickness average rate. which should be greater than 1. Yeah, so all the thickness should be thicker than 1 millimeter, because if it's less, then you can, yeah, you need to be to take care that the models will be still qualitative optimal afterwards. So the thickness should be greater than and less than. So let me go to here and say 5 millimeter. Laura, is that good? Yeah, just only
Yeah.
just an example. Yeah. Okay, and thickness standard deviation ray, I think, can be also where is that here? Okay, and this should be greater than 1.5. So, yeah, let us do one more due to the volume. So we would like to have not like, or to be sure that we don't have any like surfacing features or surfacing models. So it should be greater than 0.001, so that if, or we want to be sure that not only surfacing models, it can be printed for sure, but we want to be sure that we have somehow some models. So therefore we have a here less number. Okay, so let me going to save it. I save this filter, and now we go back, and the really nice feature is now to say, okay, please use the filter. So please see we have 13 elements here, and if I click on that and apply this function, so in really less time you have a now the list which is now optimal for this printer, because we have here models which now obviously are suitable for our HP printer, in this case 4200. So here we have models with volume values that are yeah, greater than 0.001. Okay, that is for sure. Here we have not a limitation, but for the bounding boxes, we do have one. So that means less than yeah, 318, 80. Yeah? So all these models would be optimal for the HP printer. Yeah, so we can go also again inside and see, okay, this model looks like this one here. So it's a typical plastic model, I think. And this one can be easily due to the freedom of the printing, 3D printing. It's optimal to take a additive manufacturing machine. So that's perfect. So here in this case, you can create much more criteria. Yeah, so that means for much more machines. Yeah, so to make filters, you can manage here them. You can rename them. You can edit the filters to make much more criteria, and you can download the filter to export the filter to make a backup, or to, if you change your calculation machine, to import later on your filter again. And also for sure you can delete the filter if you don't like this one. So here in this case, yeah, we can set up how many parts will be shown in the first page or in each pages. Display unit is millimeters, and here manage database is to analyze more incrementally the folder or the database, based on your files or folders. And for sure, you can also clear the database if you want. So this Partfinder, as you have seen, it gives you a really quick overview, to be suitable for your 3D printer. So now, I would like to give my word to Laurent, and will stop sharing my screen, and Laurent will start his yeah, with his screen now.
Okay, let me share my screen. Okay, I hope everyone sees it.
Yeah.
So what I'm going to show you now is our brand new 3D batch nesting tool. And as you can already see, it is based on the Partfinder, so it's integrated in the Partfinder. So what you can do is everything that Fuk showed you is that you can filter your whole database to find applications for 3D printing, so to find use cases inside your big database. And based on that, you can then set up your machine, your shop floor, depending on which technologies you use, which machines you have to send the data to your 3D printer. So what I'm going to show you now is actually a video from our development, because the batch nesting tool, it works perfectly, but we don't have an official release version yet. So what I'm showing you now is the video of our development. Okay, so as you can see, it is also web-based, because it's directly implemented in the Partfinder. So first of all, what you can do is set up your machine, your shop floor. So you can name it and select the machine out of our database of different technologies. And what you then do is the next step is to define a print job. So you, for example, you name it like a specific customer or the date when it has to be printed. And then you can select out of the database which has been filtered by the Partfinder, for example. You can select the different parts you want to add to this printing job. So now, based on the different criteria, the size of the model, also, of course, the material you want to use, you add and you select how often you want the parts to be printed. So it's basically like a web shop, and everybody who is part of the process can have access to a 3D printer and just throw parts that have to be printed in a build job. So what we see here is we have created a job with 3 different parts, and what we can now set up is different. I will pause it at this time because it's a bit quick. We can set up different parameters for each part, so we can really individualize the degrees of freedom for each part. So you can set up how many rotations are allowed. The distance to each part can be selected individually also. So it's not only global parameters that are applied, but you can really specify it for every part according to the print 3D printer, and also it's really relying on the part, because you know, there are, for example, really dense parts with a high material density, which then you have to define a bigger distance to the other parts, so that you can make sure that inside the machine you don't have any temperature problems. So at this in this case here, we can really set up the whole machine depending on the parts we want to print. And then, of course, there are also global parameters for the whole machine. So we can specify for certain parts, but also for the rest of the parts, just set up global parameters, add this to the queue, which is then batch processed. And then we already see the result actually of the 3D nesting. We create an image file so that you can see the result, and at the same time, of course, you can choose in which format you want to export the file. In this case, it's 3MF, to be able to use it in another slicing software, for example. So you see here, this is the last result. It was just the remaining parts. What we do, we fill up different machines, and we stop when we have put all the parts inside the machine. So in this case, we just have almost half of the machine filled, which is no problem. We can just print out a smaller machine, or even we could wait for other parts to come in, set this in set this machine in a queue, and wait for other parts to come in, and afterwards, as soon as it is full, send it to the 3D printer. Yeah. So basically, that was it. Really quick overview of what the 3D batch nesting tool does. But I hope you got a good idea of how it works. So as I said, it is based on the Partfinder. You can really quick and easy set up filter criteria, like we've just shown. And then based on these parts you want to print, set up your shop floor, your machine park, and then send, like in a web shop, just add the parts in the shopping cart, in the different print job, and the parts are then automatically 3D nested with the criteria you can set up for each part individually. And yeah, you get a seamless workflow to create, to fill up your machines.
Yeah, thank you very much, Laurent. That gives us definitely one really good overview of the batch nesting, because this integrated solution, next to the Partfinder or in the Partfinder, enhances the whole process, to be completely to cover all this workflow, until the batch nesting. So so now I will switch back to my screen.
Yep.
So so here in this case, I switch back to the to the slide. So we are nearly coming to the end. So, but we are really just in time. Yeah. So not like in the last webinar where we had the a lot of information of for the additive to be mentioned here in this case. So what Laurent has mentioned is that the high packaging density is will be given here in this case, because all the models will be checked as well, due to the collision, to not have any penetrations between the 3D models, and the nesting of parts and assemblies will be done fully automatically with various types of methods. So based on our algorithm, we are offering a lot of let me say nesting solutions due to the 3D models. And here the settings can be used for all major machine types. So in this case, here in this picture, also in the last webinar, this gives you the idea how is that working. Then afterwards, you have the results, different results to to spread them to your machine park. So yeah, so let me say for the first time the economical production of small batches and spare parts is now possible. Yeah, based on the Partfinder and batch nesting, that gives you a pioneering technology, I would say. Yeah, that enables companies to identify the potential parts for 3D printing and to do the batch nesting fully automatically in one whole organization. So in this case, yeah, we would like to thank you for your attendance and we hope that you liked our webinar and welcome you also to the next one, what will be published in the next time. So if you have any questions, then please, yeah, write us an email or contact us. So we are really happy to hear from you. So, yeah, from my point of view, yeah, thank you and take care. Stay healthy.
Yeah, thank you very much for having attended, and yeah, stay healthy. Hopefully see you next time.
Okay, thank you. And now we will quit the webinar. Thank you. Bye.
Thanks. Bye.